Okay, so good morning, ladies and gentlemen, and welcome to the NESMA 2022 seminar. We haven't had one for some time. My name's Mark Betcher, and on behalf of NESMA New South Wales and our sponsors, I'd like to thank you for giving up your time this morning. We really do appreciate it. It's really nice to see people's faces without a TV screen around them and headsets on, actually. Since our last seminar at the Lane Cove Test Facility, our industry's seen quite a number of changes, some of which we are hoping to address today. We also urge you to visit the NESMA website, which is constantly being updated with changes to the membership details, links and uploads. We have a YouTube channel on there as well, we've downloaded uploaded all the tests that we did last time in 2019. The address is www.nesma.org.au. We've got two presentations. Also, welcome to our guest presenters today, Max Carstead, who's formerly of Plus ES, and Mark Henson from Ausgrid. We've got two presentations today, and at the conclusion of each presentation, there will be a time allocated for questions. And we request you to raise your hand, and there's going to be some roving mics around. I think Peter's got one, and the two Peters have them. For those that were fortunate enough to be at the gala dinner on Saturday night, these two people with the mics they can't sing. Okay. But before the first presentation, I'd like to invite our current honorary state president, Scott Emerson, to say a few words. Scott joined NESMA New South Wales in 2005 and held the position of a secretary for 8 years, with previous roles as president, vice president, and Scott is now the current New South Wales president. Scott has continued to be active in the association. A sitting member of EL68 Standards Committee, responsible for the ASNZS 61439 standard. Scott was responsible for drafting some of the diagrams of the standard. A licensed electrical contractor and holding an advanced diploma in electrical engineering, Scott is also a councillor on the New South Wales Business Chamber of Commerce and enthusiastic about promoting Australian manufacturing and Australian design. Scott publishes articles on LinkedIn promoting understanding of the real-world details in specifying and construction based on the standard. And Scott is the Director of Controlling Power Manufacturing Switchboards on the Central Coast of New South Wales. So welcome, Scott.
Thank you, Mark, and I just have to say thank you for giving up your time today. Everyone's quite busy at this time of year, and we delayed our seminar for some other date issues. It's been about 3 years since we ran a seminar, and as I said, it's great to see you in person. COVID began in January 2020 with mixed feelings around the world. This changed quickly and lifestyles began to evolve. We've closed the borders, had lockdowns, Zoom and Teams calls in pyjamas, well hopefully at least wearing pyjamas, LGA zones, toilet paper shortages and homeschooling, and I'm pretty sure that there was some alcoholism issues with the teachers during homeschooling. I know that was an issue at home. The teacher got the sack. Some embraced these changes better than others. We've worn masks at work, masks in the shops and on buses and trains, and some even masks in the car when they were alone. We've learnt to appreciate things that we took for granted and evaluate lifestyle previously unconsidered. While flexible working conditions suited some, others struggled and needed the work environment and the people contact. Here in New South Wales, we were fortunate to take an alternative stance to some other states. We felt for our friends in Victoria and the lockdowns that were far more strict than ours, and we had discussions on this during the conference on the weekend, and I have to say that those conditions that they dealt with in comparison to us were extremely onerous. Caravans and four-wheel drives were in short supply in regional areas viewed as quite desirable rather than being in the bigger cities. This COVID thing changed many aspects of business, with shortages in stock, electronic and smaller components that make up parts of larger equipment. We continue to see challenges today with the impact of these issues. We've seen extreme weather events like a 1 in 100 year flood twice in a couple of months. While we've endured high water and bad weather, our friends in Lismore and the Northern Rivers are still suffering from these events and struggling to rebuild. Western New South Wales is currently under flood, and as the waters continue to push forward, everyone downstream of this is waiting on this impending onslaught. Equipment supply is an ongoing challenge, and while we work with our suppliers to ensure stock, shipping is in high demand, and the freight costs of this shipping have doubled, tripled, and even quadrupled. We've seen records of up to 10 times the cost of freight of what it was originally done. This has led us to deal with shortages in different ways. Some of us have decided to hold stock of certain components. That's a costly capital exercise for us. In some cases, it's been necessary. We've found other ways. We're recommending to our customers that all the switchgear be purchased immediately on the placement of order. Progress claims then getting that onto our shelves, working together with that supply of equipment, help mitigate the delays in final deliveries. While some might see this as an onerous challenge on business, but passing that back on to builders, where you might find that a $10 or $20 item, a rotary handle, a circuit breaker or a trip unit might hold up a $100,000 or $200,000 switchboard from energising. It's quite serious that we actually try and work together to overcome these issues. Once the borders were closed, we ended skilled migration and international staff and work visas. This has continued to lead to a staff shortage in our industry, and I'm sure in yours as well. We encourage young people to take up these roles, but this often takes 4+ years to complete. We see technology changing in our sector, and this change moving faster than legislation in policy. Increases in solar input, battery storage, and the instantaneous demands on power for fast charging of EVs. All of these aspects result in challenging times, but working within groups like NESMA allow the support of friends that we may compete in business with, but will happily supply a part off our shelves if it means helping them. As a group, we continue to build relationships and work with our suppliers, electricity retailers and distributors, standards, Business New South Wales, and service rules committees and fair trading. We assist in providing a technical view of our industry on these groups and ensure that we assist safety, technology, and in some cases simply bringing a reality to the table. We work with our NESMA partners in other states on national issues, offer differing in views on how things are done in each state, sometimes leading to somewhat robust discussions. Our drive now as NESMA, as Mark mentioned, was to increase our presence and more social media articles, providing more technical comments and assistance to the industry. And days like this present us with the opportunity to talk face to face on topics that aren't necessarily on the agenda. So if we're walking around afterwards, feel free to have a chat. It's been a pleasure being a part of this association for such a long time, and I look forward to continuing this into the future. And just before I depart, some notes about our sponsors. Our sponsors provide the funding, the effort and the support to allow a day like this to happen. As NESMA, we're a completely voluntary organisation. Our sponsors today, the platinum sponsor is APS, gold sponsors Australright and Oriental Copper, Eaton, High Switch and Modutech, IPD, NHP and Schneider. Our silver sponsors CBI Electric and LTEC. And I'd like you to just put your hands together and thank them for the efforts that they provide in allowing us to get together like this. Thank you, and I do hope you enjoyed the day.
Thanks, Scott. Thanks for that, Scott's very good. And interestingly, we've had a dinner and we had a national conference yesterday as well, and we had members from other states. And it's interesting to note that other states are all experiencing the same issues that we're experiencing in New South Wales. So it's our first presentation is titled "The Standards and Us" and will be presented by Max Carstead. Max was the supervising officer of the Lane Cove High Power Testing Station for just under 40 years before its closure. He was the NADA approved signatory for all tests performed at the test station, was the International ASTA Observer, the ASTRA-approved signatory for all tests performed at the test station, is an ARTA Laboratory Technical Assessor, holds a seat on the IEC 121B MT2, the International Switchboard Committee responsible for the IEC 61439 series of standards, and IEC TR 61641 LV arc fault. He sits on EL68, the Australian Switchboard Mirror Committee. He sits on the EL26, the Australian Mirror Committee for 60529, the IP test standard, as well as sitting on various other LV and MV Australian committees. Welcome to the stage, Max Carstead.
Thank you, Mark. Seems I've been doing a lot of sitting in my life, but now it's time to do a bit of talking. Unfortunately, the talking is a very bland subject, but it's something that we all need to understand and to recognise to do our jobs properly. So the first slide here just indicates that these standards are designed to protect us and give our clients and they give us some of our biggest headaches. So as said, a lot of my time was taken up testing to 1136, AS3439 and the 61439 series. And I'm very involved with the production of the standards that we're talking about. So the primary standards for switchboard testing over the years have been the AS1136 that Mark would be very familiar with. We then transformed, which involved a certification by 10 type tests. We then went to the AS3439, where we also included a few additional type tests, so into 12. And then the monster standard 61439 came, where the certification was by 14 verification tests. Non-compliance with the standards can be catastrophic. I'm not sure if this is one of Mark's boards, but a little DB. But you need to get it right to avoid anything like this. The standards are there. There are so many of them, and I've got a list of quite a few that would be useful to you, but they're all so expensive as well, and to build to them without having them is a bit of a risk of faith. The history. Now, AS 1136 in 1980 was based on the IEC 439 Part 1. We then went to the 1988 version, and which differed significantly, but here we have IEC 439 as identified in the Appendix L of this particular standard, with clause numbering different between the two documents. We then went to the 1993 version of 3439. This aligned more closely to the IEC 439, with the exception of appendices AA to HH. And here the clause numbering between the IEC document and the Australian standard was maintained. In 2002, we went to the next 3439, and here we see the first adoption with national modification. So we've actually got the IEC document that's being adopted and then made into an Australian standard. In this document, it was a lot easier to read because you had strike through and shading on the text to show you where the modifications actually occurred. So from 3439 in 2002, there is in the preface of this Australian document, all type test approvals gained in accordance with 1136, 1988 and 3439, 1993 still remain valid. So this is the 3439 saying the previous documents were still current. At this point, 2002, we see the standard appeared to stagnate, partly due to the introduction of the 61439 series, where the draft had been rejected several times in the IEC community before it was finally adopted, warts and all. So finally, the IEC 61439 edition 1, 2009 was published, and it cancelled and replaced the fourth edition of the 60439, which we had been using as our parent document, and was obviously deemed to constitute a technical revision. The IEC 61439 series introduced the concept of a general rules document, or Part 1, as used by other standards, and then this led to the introduction of the subsidiary product part documents as follows. So we have Part 1, which is the general rules. Part 2 is the actual document you're building your switchboard to, which is the low voltage switchgear and control gear, which is the assemblies or the PSC assemblies. And then Part 3 covers the distribution boards intended to be operated by ordinary persons. Part 4 is assemblies for construction sites. And Part 5, assemblies for power distribution in public networks. Part 6 becomes the busbar trunking. And then the assemblies for specific applications as marinas, electric vehicle stations are found in Part 7. So finally, in 2016, the Australian Committee adopts the 61439 series, so that's when we get AS 61439. And so we have Part 1 and Part 2, which are then modified adoptions of the second edition of the IEC document. The terminology changed with the introduction of this series, moving from type test to verification test. And the method of verification was expanded in this document to include verification by test, by comparison to a reference design, and by calculation. Now there's a warning. If you are using the Australian standards, if you see the 3 letters on the front cover of the document, MOD, that's where you need to take care. It means it's a modified adoption. So Standards Australia no longer shade or provide a margin bar or redline versions to indicate the text forming the national deviations. So when you see the AS-NZS standard is published with the IEC document you actually see the IEC document occurring in the front of the AS standard. So that has the complete IEC document with all its text, and then the Australian modifications only appear in the rear of the document under appendix or the annexes like ZA to ZZ. So what it means is you have to read the back of the book first, typical Australian, and then apply that text to the front of the document, which may be misleading or cause issues. So be aware of that with a modified document. So the AS Part 1 and Part 2, in the preface of Part 1 and 2, state that the AS-NZS 61439 series will supersede 3439 5 years from the date of publication, which is 5 years from 2016, which gives us the 2021, hence the problem in industry over the last year or so. During this period, that low voltage switchgear and control gear assemblies may comply with either series, and after the 5 years it is anticipated that the 3439 series will be withdrawn. That particular document, the 2016 AS, says where tests on the assembly have been conducted in accordance with IEC 60439, 61439, or the AS-NZS 3439 series, and the test results fulfil the requirements of the relevant part of AS 61439, the verification of these requirements need not be repeated. So what I thought I'd do is just a little quick comparison. In these particular clauses, so we'll look at the current standard. Clause 10.5 under the 61439 is protection against electric shock, which is the old 3439-824, the protective circuit verification. 10.4, creepage and clearance, which was the previous 825, verification of clearances and creepage distances. 10.13, mechanical variation, used to be the old 826. 10.3, degree of protection, was the old clause 827. And 10.12 under 61439 was the old 8.2.8. Under these clauses, we're seeing no real technical change, and so anything that's done in the previous 3439 is applicable in the 61439 series. We have some minor changes starting to appear, and what happens in the dielectric test of 3439, which is 822, the power frequency test levels were slightly higher, and we only had 3 impulse tests on each polarity to validate an impulse rating for the assembly. So clause 10.9 is the new clause for 61439. Here we have the power frequency test levels are slightly lower. Test durations were reduced. Even that said, they went down like to a 5-second test duration. But that said, the latest edition of Part 3 is taking it back to a minute anyway. And then for impulse tests, we had 5 impulse tests for each polarity. Looking at that, some certification bodies don't see a difference between 3 impulse positive and negative and 5 impulse positive and negative tests, but there is a difference, and compliance theoretically should have an impulse test series with 5 positive and negative tests. The short circuit, the old short circuit clause was 823. With regard to short time withstand current tests, against the new clause of 1011, there are no differences. The test is identical, and so there's no change. So if you've got a test of 50 kA for a second under either document, there's no difference in the requirement of the test or the results of the test. In the 823, it was not deemed necessary to carry out single phase or neutral brake tests on 3-phase breakers. What there is in 1011 is, and earlier construction clauses in the 61439 series, it's saying that the equipment chosen to be fitted into the assembly should be applicable and suitable for its use. And so what happened in the certification bodies were pushing for complete certification under short circuit conditions where you're testing protective devices. They were saying you can do or you should do a 3-phase test on the protective device, but also in service it will see single phase operation, either single phase test to earth under a fault condition or a single phase break to a neutral if there's a single phase fault. And so validation for short circuit under the braking capacity test would be deemed to be appropriate to do a 3-phase and single phase test on a protective device or a functional unit. We then look at temperaturised test. One of the things I like to enforce or reinforce to people is under this temperaturised test there's no real change in the performance of the test because I hold the opinion, and I believe it's irrefutable. For a unit with a nominated test current, there is a fixed temperature rise that is attained. So if you've got a certain amount of current in a fixed box, with that current you will get that temperature rise for that unit, unless you start changing ventilation or something else, but it's a fixed quantity. So the presentation of the result against the 3439 may have been with or without a diversity factor applied. To the current is the main issue that I see here. A test of 3439 where a diversity of 1 was used, the test is transferable. If you had a diversity of 0.8, then the test isn't directly transferable, but you could say it's applicable if you assume the 0.8 result was the actual diversity 1, so you're actually derating the unit, and then you can utilise that test under the 61439. But the complication here comes with under 10.10 for temperaturised testing. It's been expanded to 4 test clauses identified so you can interrogate the performance of the units, the buzz bars, the assembly as a whole, with and without diversity. So that's broken down into these sub-clauses, 10.10.235, which is a temperaturised test on the entire assembly, and that's where you actually say the 821 test is sort of transferable into that particular clause. The 10.10.236 and 10.10.237 break down the test into looking into the performance of individual functional units and the complete assembly, and also looking into the performance of the main bars, the distribution bars, separately, as well as the complete assembly. The 61439 also brings some additional clauses in 10.6, 10.7, 10.8, which is the incorporation of switching devices, internal electrical circuits and connections, and terminals for external connections. The three clauses above are not validated by testing, but they were handled roughly under the 3439 by considered under the construction clauses, but not identified as type tests. So major changes that are really coming in are the clause under 61439 at 10.2. This clause is titled Strength of Materials, and you have minimum mandatory performance requirements which are to be verified by test. Resistance to corrosion, properties of the insulating material, so glow wire tests on busbar supports and plastics that are used. Resistance to UV for the external enclosure, a lifting test, mechanical impact if required, and marking. So those particular areas were loosely handled, I believe, by the combination of construction requirements, but they weren't verified by type tests. But that performance was based really on the quality of the build by the manufacturer. So there is another document which comes to the fore with the 61439 series, and that's called the Part 0. Australia has adopted that. It's ASNZSTR, meaning a technical report, and so it's not a standard and it's informative only. But what it does do, it contains assembly system and application details that should be specified to ensure that the assembly supplied is fit for purpose. It enables the manufacturer to produce an assembly that meets the needs and expectations of the specifier, and it provides an explanation of the assembly characteristics and options within the 61439 series. So it provides guidance on how to select the appropriate options and define characteristics to meet specific application needs, assisting in specification of assemblies. References within this document to the characteristics of an assembly and the requirements with which they will comply assume that the assembly itself is designed, manufactured and verified in accordance with the appropriate and relevant part of the 61439 series. Now, in these documents, in this particular document, we have tables C1 and C2, and that enables for the characteristics to be recorded and agreed between the manufacturer and the specifier. So a very useful table if you're trying to negotiate an assembly for someone. That table also appears in Part 2 under as Table BB1, which is in Annex B of the 61439 Part 2, which is the actual switchboard assembly. So as I said, I haven't got a copy of the table, it's a little bit long, but it allows you to identify each element of the assembly and what you actually need it to do. Another standard that comes up, which is the 60890, the 2009 version, is a method of temperaturised assessment by extrapolation for partially type test assemblies of low voltage switchgear and control gear. This current document is based on edition 1 of the IEC. However, it has been published as a standard through the IEC, even though it's only a technical report. This particular the parent IEC document has been superseded, but it has not been adopted by Australia as yet. The superseded edition, which is edition 3, is turning into a very useful document. This latest version, it provides alignment with the IEC 61439 Part 1 and Part 2, which are now up to edition 3, even though Australia is still only using the edition 2 at the moment, but does intend in the fullness of time to adopt this edition. It has individual annexes which give technical explanations to the effect of an uneven power distribution, additional temp rise due to solar radiation, effect of different enclosure materials and paint coatings and colourants, effect of different natural ventilation management, the effect of the forced ventilation management, power loss calculations, and impact of an adjacent wall on assembly cooling surfaces. It provides for maximum internal ambient temperature limit into an assembly. Validity of the calculations for such assemblies, it was extended to 3200 amps. And there's an addition of an algebraic equation for different characteristic curves for temperature rise of air inside an enclosure included in the document, rather than just doing it off some curves. So, as this is a very bland shot, I thought it was time to wake you all up. Here we have a series of 400 volt buzz bars. There is a bit of plywood over the top, which was applied as screening to stop inadvertent touch with the contact, with the buzz bar itself. There's a steel rail on either side of the buzz bar, with buzz bar spacings just over 100 mil. But what we have is protection settings were set too high, and you've got a duration where it was an IDMT protection relay that was resetting. So with a 400 volt test, the arcing starts moving away from the source of the supply, and it will self-extinguish. But if the conditions for arcing are still present, it will continue until protection operates. So we'll see what happens. So this was a recreation of an in-service failure that we did at the laboratory. So even though the 400 volts has no pre-arc, you have to be very careful. Of course, this leads me into arc fault. Must be first... Sorry? Oh, that was only 40, 45 kA, probably at the bars. So it must be identified. Arc fault and arc flash are different terms, with arc flash often being used incorrectly. An arc fault is used to identify tests performed on an assembly to show its ability to withstand an internal fault without endangering an operator in front of the assembly at the time of the fault, and whether it prevents transfer of the fault to other sections of the assembly, and the suitability of the assembly after a fault for a further service. And compliance with that is usually determined by the guidance documents of our 61439 2016 Appendix ZD and the IEC TR 61641 Edition 3. There is another standard that has been developed by IEC, which is the 63107 2020, which is the integration of internal arc fault mitigation systems in power switch gear and control gear, PSC assemblies according to Part 2. And because of the differences in test indicators, the test to ZD compared to IEC TR 1641 are not deemed to be comparable or transferable. So the arc flash that I mentioned earlier is used to identify tests performed on personal protective equipment or clothing, and its ability to withstand a nominated arcing current energy levels at nominated voltage levels. So without endangering an operator wearing the equipment or clothing when working on, in, or in front of an assembly at the time of the fault. So these tests determine the arc energy rating or calories per centimetre squared, and compliance is determined with the following guidance documents. So IEC 61482, the ASTM F1959, NFPA 70E, which is a number you might see, and the ENA NENS 09. So using the Appendix ZD to determine an arc fault performance of an assembly, This document specifies two types of tests, one known as a standard test and one as a special. The standard test is conducted with a shorting fuse wire installed on the load side of the protective device inside a functional unit. The special test is conducted with a shorting fuse wire installed in any other position, including the line side of outgoing units, protective device, distribution bars, main bars, or on the line side or load side of the incoming unit. Tests are only done really at the discretion of the manufacturer or by agreement between the manufacturer and the end user or specifier. And the indicator cloth used for an Appendix ZD test is installed 250 mil from the front of the assembly to a height of 2.5 metres. And it's a thin white cotton, a double layer of cotton gauze. The arcing fault using the 1641 edition 3, this document goes a bit further and specifies various test positions such as the load and load side of outgoing units, distribution bars, main bars and line and load side of the incoming unit. The test positions identified cover the standard and special test positions. All tests specified can be performed or selected tests from the nominated points or can be performed at the discretion of the manufacturer or by agreement between the end user and the specifier. Indicator cloth is installed on all sides, not only the front of the assembly, or in positions nominated by agreement between the manufacturer and specifier. And the indicator cloth is in 300 by 300 squares, 300 mil away from the assembly, and at a height of only 2 metres. But the indicators are then installed in a checkerboard fashion. So other helpful standards that can be used, the IEC, which is not adopted by Australia as yet, edition 3, introduces the concept of an ING, which is, or a group rated current, in order to help explain the appropriate use of rated diversity factor. The ING current is the current that can be carried by a unit circuit when it's loaded continuously and simultaneously together with at least one other unit or circuit in the same assembly or section of assembly. So what we're getting is the rating of the particular unit being affected by mutual heating from units alongside. It also introduces a very useful formula that we used at the station for many years. And that particular station, to reduce testing required, to determine the rated current of a circuit, the maximum permissible temperature rise, and that current may be calculated from the actual test current. And so what it does, it gives you a way, the standard limits it to a plus or minus 5 degrees, but it does give you indication, if you go above that, the performance of a unit at a nominated current compared to a tested current. So it's a very useful formula, and it can be found in the edition 3 of the 61439. Edition 3, Annex DD, assemblies for use in photovoltaic installations. This annex specifies a solar radiation test and a test method. This was not added for PSC assemblies, but was designed for photovoltaic installations. And it does provide a relevant sort of test method for assemblies that might be installed externally. The intent of the IEC committee is to remove that Annex DD and make it its own standalone standard, which then it would be lost in the Part 2 version. So we'll see, just watch this space, what happens. 62208, which is the empty enclosures, so where you can test an empty enclosure for suitability, and it is cross-referenced in the 61439 series. 60865, edition 1, Part 1, Edition 3, gives you short circuit currents, calculation of effects, and definitions and calculations of methods. Australian Standard 4278, 1995, is a withdrawn standard, a method for assessing short circuit withstand strength of partially type tested assemblies. Australian standards have a methodology, once the standard's over 10 years old, they want to withdraw it unless the committee is active and wants to reconfirm the standard. So there are a lot of standards that can be pulled and withdrawn, even though they might still be wanted by the irrelevant industries. 3865, calculation of the effects of short circuits. IEC 62262, degrees of protection provided by enclosures against external mechanical impacts. And then the 60529, which is reconfirmed and under interrogation, the EL 026 has just been reformed, and they're looking at adopting the latest 60529 for IP enclosures. We have a series of the 68 series, 211, environmental testing, the salt mist and the damp heat. They're used for the corrosion test. The 275, the hammer test for impact, and the 26, environmental testing for vibration. We have a few others, which are the IEC 63208, which are now sort of coming out in the IEC world for cyber security. 63216 for EMC assessment. 63196, energy efficiency, and then the standard number's missing there, which has just sort of come to the fore. And I have a number here, which is a 63058, which is environmental aspects. We do have one other major standard in Australia, of course, which is the AS3000. I unfortunately listed as an unhelpful standard at the moment to you all. The referencing of AS3439 and the 61439 Part 2 has led to all sorts of confusion. Watch this space under 3000. EL1 are looking into various amendments to try and handle this for the industry, but we'll just see how it resolves itself. Thank you very much.
Thanks, Max. Thanks, Max. Very informative, as usual. There will be a prize awarded outside for anybody that can name 5 of the helpful standards in alphabetical order. Our next presentation is titled Building Compliance Awareness, and will be presented by Mark Henson from Ausgrid. Mark is passionate about the electrical industry and the safety of electrical installations in general. He has been a member of the Installation Inspectors Group with Ausgrid for over 11 years, and he has seen the good, the bad and the ugly. Mark is responsible for ensuring his group are kept up to date with industry and standards changes, whilst also helping Ausgrid adapt and install its own renewable energy initiatives within its own network to deliver network stability. Mark is also a committee member for the Service and Installation Rules of New South Wales, which is currently under review. And just prior... Oh, sorry, that's next. Mark, welcome to the stage.
Thank you, everyone. Pleasure to be here today. I'd first like to kick off with congratulating each and every one of you who are here today, just like what Scott said at the start. It is time out of your day, but I look at it in a little bit of a different frame of mind, that you're clearly passionate about the safety of the installations that we all work on. I think, to me, that deserves its own applaud, to be honest with you. So congratulations for that, guys. Trust me, as we said, when we see the bad, it's clearly no one that's in this room. Some of it's absolutely shocking. So, look, hopefully with our presentation, we'll be able to go over a few things here. So why does an II do what we do? Okay, there's reasons why we are around. We're not just there for no reason. So we'll go through a bit of that quickly. Our switchboard review process, I know that there are a lot of questions at times from switchboard manufacturers, from electrical contractors, consultants and all the rest of it, so hopefully we can provide a bit of guidance on that. And then the service rules update as well. So my presentation is going to be fairly short and sharp, hopefully enlightening with some of the photos that we have, and also hit me with the questions that you've got, and afterwards as well as need be. So here's an ugly bunch of blokes. As you can see, there are some who are no longer here and some have joined on. So overall, we've got about 25 in our group in total. So hopefully we'll be growing that by 1 or 2 in the near future. and unfortunately some of those guys on that screen there have also departed as well, but have been replaced. So most of these guys here will just be electrical contractors at the end of the day. That's their level of training, and there's various reasons as to why we've gotten to where we are today. I remember reflecting on before coming to this presentation and thinking, why do I actually do what I do? And I think getting into the electrical industry probably started from my grandfather playing with the train set. And I thought, I can make this train set better. I want those flashing lights to cross over when the train comes near. So a few little shorts later with some relays and whatnot, and we got that working, which was great. But what got me into the compliance section, and it was probably the third day of my apprenticeship when I actually saw one person die and someone nearly pass away in front of me as well. So as a third day apprentice seeing that, I thought, this is not okay. I want to do something about that, hence the passion of safety and everything in there. So as for what is an II, it's pretty straightforward, installation inspector. So the installation inspectors sit underneath the service and installation compliance group that's within Ausgrid, and that forms a broader part of the operation, installations and emergency response unit, which has the operators and emergency service officers, the EMSOs, as we currently hear. So between that big group, we're a pretty tight group now, and we can effectively get a lot of things done pretty quickly. So why we actually do what we do, and it all comes down to legislation at the end of the day. There's two main acts within the electrical industry, the Gas and Electricity Consumer Safety Act, which is currently under review, and there's also the Electricity Supply Act. So from the Electricity Supply Act, that's where our distributors kind of sit in there. So that's what we generally have all of our powers underneath, our powers of entry, powers of inspections and all the rest of it. And that's purely just to make sure that as a network, our network is as safe as it can be and as sound as it can be to continue to supply power to all the installations in our distribution network. So it's not about going deep down into the installations anymore, because those powers back in 2016 with our lovely power of choice, beautiful piece of subject that was, changed some of that legislation. So the distributors no longer have the need to ensure the safety of the customer's premises that is connecting to our network. So with that, you've seen that sort of pull back a little bit from the installations, from an inspection point of view. It's unfortunate, but hopefully we'll have Fair Trading are out there. They do have some inspectors out there in New South Wales, and they are out there inspecting and picking up on some things as well. So underneath the Electricity Supply Act, we got the Electricity Supply Safety and Network Management Regulation. So underneath that is what has all those powers and the requirements as a distributor of what we need to do. Righto, main switchboard review process. This is one of the more tedious parts that we have. So as you can imagine, electrical contractors or whoever is getting an installation put in there, there are no names on these drawings, I hope. So we can't pick on anyone or laugh at them. But this is one of the drawings that we will get for a review. And just like you're seeing there today, that's what you're looking at on a screen. So as you could appreciate, generally our senior inspectors will review one of these drawings on a screen, and we're supposed to get a rough idea of what this switchboard is going to look like. As you can imagine, we're looking at a 2D object there, let alone on the day when we're turning up, looking at a switchboard that's actually constructed that we can touch and play with. So often my IIs will get a bit of hesitation when they might identify that there is an issue with the switchboard, and they'll go, but this has been approved already. Later on, you'll see there is no approvals that we get by looking on a computer screen. It does not tell us what you're actually going to deliver. That there is going to be revision A, and it's probably revision G by the time it's actually on site. So as you can see there, so you've got your general sort of drawing, then you've got your single line diagram. So you're looking through a very general quick look around there, looking for obvious things, looking for CT isolators, are they in situ, and any of those sort of big ticket items that we can pick fairly easily off there. We will be looking at form ratings, IP ratings, current ratings, and the likes of that as well. Looking at the actual location of the switchboard, quite often we'll see a long set of consumers mains or service mains coming into the building. On top of your Australian standards, on top of your New South Wales service installation rules, you've also got distributor requirements as well. So it's the same for any distributor. You need to make sure that you're you're quite savvy with those standards within there. So we've got a network standard 112, which will talk about the length of those consumers' mains and how long they can or can't be. If they are longer, and it happens very easily, especially with the way they are currently drawn up at the moment, which within Ausgrid is under review, hopefully to come out soon, they are very short. Because at the moment, if it's a substation supply, it's immediately adjacent wherever practicable. So that means the next room, not 50 metres down the opposite end of the building. So at those times, if we are not aware because we were never given this diagram here, it could be a very easy one that we've just paused the installation energisation, and I know how much stress and anxiety that can cause for the job site because we have milestone payments and all the rest of it. So the guys in orange, we are well aware of what those ramifications are, but again, we've got that legislative burden on us to make sure that it is compliant to the standards and our requirements as well. So they've sort of got like a bit of an overarching single line diagram for the whole site. So you can see up from the top there, you've got the two substations up the top, and then it sort of all filters down from there through your main switchboards. You might have generator connections, PV connections, and all the rest of it. As much information as you guys can give us is the only information we're able to provide a response on. So often we will get to site and we've been given about 10% of what the actual is on site. That's going to make it pretty hard for us to continue on with an energisation if we find issues with this other part of the installation we were never made aware of. PV, downstream of generators, you can't have that. It's supposed to be connected upstream. But there are other parameters you can put in place if need be. So that's where we'll be saying, can you now provide us that information, please? So having all the information given to us up front will make it a much more streamlined approach to be able to get you guys energised as soon as possible. And I do need to, I guess, state to an extent, we are in the business of connecting customers because an unconnected customer does not create revenue for anyone whatsoever. It's just that we need to make sure that it is as per the standards. So this is the lovely compliance statement that we get a lot of feedback about. This is from, so although it's just got Ausgrid's name on top of that one, that's because we personalised it for us, but this is a state document that was, the letterhead that came with it has got all three distributors' names at the bottom of it. So we are looking at that. We have taken some feedback back from NESMA switchboard builders. There are some things there, some sort of confusing bits and pieces there. But again, rather than guessing it, please reach out and ask the question. There's nothing worse than guessing it, getting it wrong, and then having to do it again. So doing it once would be better than doing it 2 or 3 times. Where it says report numbers, that's exactly what we need to put in there. We put a report number in there. That doesn't mean a generic number that you guys have just decided to make up yourselves as a switchboard builder or electricians. It actually needs to reference the type test report potentially that you've undertaken. It's a very quick review, again, for our guys, where if we're seeing those report numbers there, if it matches what we're looking at for the switchboards, again, our guys have gotten pretty savvy with some of those report numbers coming through, and they'll have a rough idea what those report numbers should be looking like. And it's pretty easy to turn around and say, hey guys, I'm not too sure about that. Can you maybe send us the first page of that test report just to verify that that test was actually done? Can't stress enough, when we, as I said, we shook the tree for 3439, merging over to 61439. It was pretty disappointing how many switchboard builders could not prove their compliance to 3439, let alone to 61439. I even had one switchboard builder tell me, not in this room, one switchboard builder tell me it was industry practice. And that just absolutely blew me away. When I was expecting a handful of people, not a significant percentage of people, were coming out with some of these outrageous claims, I pretty quickly bit back and said, well, what's industry practice? Is industry practice committing fraud? And they sort of, well, what do you mean? I said, well, you've put a label on the front of this switchboard saying it complies to 3439, but you can't actually tell me that it does. You can't prove that it does. As an inspector, as a DNSP, we are not saying that your switchboard doesn't comply. You just have not yet proven that it does. And that's where Max was talking about before, about all those certification, that documentation that is required to prove that compliance. That is generally what's missing. So if consultants in the room, contractors in the room, make sure that that switchboard you're buying is backed with that compliance documentation. Otherwise, you might be spending a significant sum of money for it to turn into scrap. You might be able to recycle some copper out of it and some functional units out of it, but everything else is going to go to the tip, and then you're going to be rebuilding another board. And sadly, it has happened more than you'd like to think, unfortunately. So it is what it is. I look at a main switchboard as a bomb that just hasn't gone off yet, because that's effectively what it is. You saw the photo before from Max. We've seen some shockers at that test station. Some of them were obviously set off on purpose, usually the NESMA. Boards are always, well, I don't know what it is with NESMA board builders, Max, but every time I've been there, just watch one of their boards, it always blows up. So. That's your one again, Mark. There you go.
The last time we did do a test, Mark, if you remember where it was.
Once. It's a good percentage.
Then nobody enjoys it, everybody complains.
Not as exciting.
Yeah.
We need one test for compliance.
What happened? Oh, it just turned. Oh, it's not exciting. So compliance statement, guys, that is what we require for every switchboard that's coming through for our review as well. Our lovely our discrimination studies. So again, being at the end of the day, licensed electrician by trade, discriminations, we sort of give it a very quick look at it. It's going to cause you guys more grief than it will really cause our distribution network. Okay, because worst case scenario, if your switchboard does not discriminate, Ausgrid's protection will likely set off, but you might be then turning off a few buildings next to the site that you're on. And we'll just stand back and go, that's their problem, guys, go recover the costs off them, because they're the ones that have not installed a correct switchboard. So you need to make sure that discrimination is correct. Okay, we do come across the occasional discrimination study that we'll pick on at the time, and we'll go, you might need to look at that. And this one in particular here is not necessarily to our network, but it's within the installation there. We've got that slight little crossover there. So there is a potential chance, depending on what that circuit breaker or fuse was doing within the installation, is what it may affect. So as you can see, it is crossing over the blue service protective device. So there is a chance that your SPD can actually function and switch off the whole installation rather than just that one component of it. And as Max was saying, that overarching aspect of AS3000, did it work in the manner intended? And I'd suggest it didn't do that. The protection worked, which is great, but not down here. It's done it up here and taken out the whole installation. So that's not necessarily a great idea. As I mentioned before, guys, you might get a review back from us saying, as far as we can see, everything appears to be okay. And that's all it is. It is not an approval that come energisation day, your switchboard will be turned on. We are going to be looking at the switchboard room. We're looking at many other aspects, how your consumers' mains are getting into that switchboard, how they're terminated, and everything else in between to look at that AS3000 compliance. As installed, the fun part. So as you can imagine, some of these switchboards have already gone through our approval process, and we come to things like this switchboard here. So this is a good example. This went through, we can see some, looks reasonable. Again, minimal information on our drawings. We looked at it and well, it appears to be okay. We're looking at, in particular, with the SPD and CT cubicles in this aspect. This is what was actually installed. So I think from memory, there was about 12 odd defects, I think, within that photo that we looked at, and quite a few of them are not going to allow energisation. So this was one on a weekend job. I was on a Saturday, so the switchboard builder's not available because they're not working on the weekends because they mustn't be that busy. But we've now got significant issues here where supply's not going to be able to be energised because they're going to have to make some significant modifications to that switchboard. You know, the CTs, you've got the CTs there, no screening. We've even got, they couldn't even get the colours right. If you have a look at the set of potentiometer fuses, you've got the one on the red phase on the left has actually got a blue wire coming out of it. So like, you see things like that and you just shake your head. But this is unfortunately some of those silly things that we are still seeing here as well. As Max was pointing on before about Annex ZD, keep in mind that the New South Wales Service Rules does require a ZC test to be done as well. So that is a special test, which effectively means ZD. So we are looking for that containment within the SPDs. This is another lovely switchboard that was 400 amp overhead supply was installed, and the ASP decided to go ahead and replace this switchboard without Ausgrid's know-how. It was only when there were some issues with the metering that this particular ASP relocated and got that wrong, is when we got involved. So yes, that is timber and a nice little FC roof that was put on an IP56 switchboard. The doors can't open up 90 degrees because of that nib in front. It was just an absolute hack of a job. There's our SPD cubicle, and yes, they did order a bottom entry switchboard, but as you could see in that previous slide, the consumer's mains are coming down that tray on the wall, so they've just decided to cut a hole in the back of the switchboard. Now, I don't know many switchboard builders are going to go, yeah, no worries, go ahead and cut holes in my type tested switchboard because that's fine, and I'll take full responsibility for that. So again, this switchboard builder has turned around and gone, we're not certifying that, guys. You've just changed our switchboard. We gave you a type tested switchboard. Our type tested switchboard does not have a hole. It is not a IP nothing. It did have an IP rating initially on it. That's the back of it. So that's our nice consumer's mains coming in there, and it's bushed. I was actually surprised it was bushed. So great job. So as you can imagine, we've now got a customer who's pretty upset because their power's being turned off, because we just can't leave stuff like that connected to our network. It's going to cause anyone a potential issue. I'm not sure if I actually yes, I did put this photo in. Sensational termination of Earth. So these are just, and it was good to hear everyone go, oh, good. Silence, I would have been going, oh dear. So yeah, as you can see, you've got lugs that have been doubled, tripled up. You've got earthing that's just the way it is, and you just shake your head. This is what we are. Not what we are. What some of you guys are competing against out there, and you wonder why. So, and then that's we had to, again, this is another switchboard, but this particular one, obviously we have bigger holes with some conduits coming in, so we're just going to cut a bigger hole to fit those conduits in, and then just put the fire foam in there and assume that that will be okay. So again, this switchboard builder has said, nope, not our problem. They've now potentially destroyed a switchboard that they're going to have rebuilt. So I'm not sure what the end result of that particular site was, but it was not very well received by the customer when Ausgrid's issued a defect for this site and not energising it and saying you're going to have to fix it before it gets turned on. So milestones have gone out the door, occupational certification goes out the door, liquidated damages start occurring, so you can imagine pretty quickly it turns into quite the snowball that's getting bigger and bigger. Moving on to server installation rules. I think it's been about 2 years now. We've been drafting it up. There was over 200 changes that were put through. Unfortunately, due to some information and some legislation reviewing, we have put this on hold effectively, waiting for the outcome. So, as I mentioned earlier, we've got these two acts that are sort of competing against each other and don't cross over very well. So there is a bit of a battle, not even a battle, but just some robust discussions, I think is what you said, Scott. Robust discussions between the two acts about what's going to take precedence, because we have different ownerships of those two acts as well. One being fair trading for the Gas and Electricity Act, and then for the Electricity Supply Act is Office of Energy and Climate Change, which used to be known as DPI. So their name changed this year, and it does every few weeks by the seams of it. So as I said, over 200 proposed changes, some minor, some major. I think I might have put some on here. So that was just a couple of quick ones there. So at the moment, AS3000 is talking about over 125 amp. In our industry, we don't have 125 amp services. We have 100 amp or 200 amp and above. So it was made mention there that, well, why don't we just make that nice and clear that when it's a 100 amp service, because there's no difference if the SPD is sitting there, if it's sit at 125 amps versus 126 amps, why are we then having to go from one standard to another?
Is that over 100 amps or 100 amps and over?
Over.
So
100.1. I'll redo the slide for us. No, as I said, over 100 amps. So, yeah. Rethink of power factor, taking PV into consideration. So we've forever had that 0.9 power factor sort of threshold there. But as we know, with the impregnation of PV onto our networks, we're actually getting that back into the Unity and beyond. So that there has been a rethink of that. So there will be some changes to the requirements around PV at that point in time. And no other equipment in the SPD cubicle. So there's the issue there is not only is it something that needs to be sealed because it's unmetered, and we've got Ausgrid or the DNSPs will want to see the settings for the discrimination set and sealed. There's the other issues there of working live. So not only is there the issues that we, as a DNSP and security for our network and being able to wind up those protective devices, if you're opening up that SPD cubicle, you'll find yourselves in strife pretty quickly with safe work, because you're now working live in that cubicle. So that's something else to think of. And also looking at the commercial industrial 25 KA minimum. So there's been it's more just reinforcing that particular space there, because as you know, the network's continually evolving, and the KA ratings can significantly change as soon as we throw a substation in just around the corner here, because someone's decided to build another block of units or whatever and put a new sub in next door. So now all of a sudden that KA rating can blow out pretty quickly after the switchboard's already been installed.
On that KA rating, you guys are trying to push that from the PLA to the switchboard?
Yeah, correct. Yep. So it's, again, looking at with the length of consumers mains, service mains and all the rest of it, it's again, don't be thinking that this stuff has to be enforced as of today onwards, because this is, as I said, it's in pause at the moment. So look at it as service rules as it is right now, not what it will be tomorrow, not what it was yesterday. We've got to look at it as exactly that. Just a general refresh and layout change as well. So the idea is at the moment, you see how it's red in the two columns. We're just going to try and make it look more like an actual standard book, and it'll be a bit of a refresh. All the drawings are being redone to sort of bring them up to today's standards as well, and hopefully make it a bit easier for when you do view it online, being a free issue. So we don't have to pay for that standard.
I would like to point out that Max said that AS3000 was unhelpful, not unuseful.
Yeah, that's right.
Just prior to today's conclusion of today's seminar, I'd just like to thank a few people. Firstly, everybody here for their attendance. I mean, this is after 3 years of being in the wilderness. I guess it's really good to see a turnout like this. I'd like to thank the sponsors for their contributions to the event, and encourage everybody here to stick around and view their products and view their stands that they've put together. I'd like to thank the NESMA New South Wales Committee for their efforts in putting together today, particularly Peter Silsby. He's done a lot of work. More importantly, and by far the least, I'd like to thank Leanne Wilson and her team from Happenings Australia. An event like this, for us, for a switchboard manufacturer, is impossible to put together. And without Leanne, we would struggle every time. And she's been doing it for 15 years now, I think. And every one of them has been a success. And I think today's been proof of that as well. So thanks to Leanne. And finally, we hope to see you at the next seminar. Thank you. Thank you.